The latest release of Argo CD, version 2.10, is out. It contains over 52 new features, 75 bug fixes, and 44 documentation updates, with a total of 230 contributors. And that was just in the initial release candidate. There's been 4 more since, and I'm sure by the time of the release, there will be even more improvements. In this video, I'm going to go over the top features from the release and provide a demo of each of them. I'm Nicholas Mori, a developer advocate at Acuity, the enterprise Argo company created by the founders of the Argo project. Acuity is the go-to platform for painlessly implementing GitOps with Argo CD inside your organization and empowering your developers. The features I'm going to cover today are the templatePatch field for ApplicationSets, which allows you to define templates without being limited to string-only fields. The ServerSideDiff compare option, which addresses issues with the server-side apply sync option. The addition of the PostDelete Hook to clean up resources after an application has been deleted. The addition of Application Controller Sync Jitter to allow the repo-server to have a more evenly distributed load during reconciliations. Support for Kustomize Components directly from the application manifest, which provides a powerful way to modularize and reuse configuration. Better support for notifications when used with apps in any namespace. So now end users have the ability to configure notifications for their Argo CD application in their own namespaces. And the addition of status panel extensions so that you can display extra information alongside the rest of the application's status. So as I explore these new features added in Argo CD 2.10, I'm going to be referencing the configuration in this GitHub repository where I have a breakdown of each of these features and the manifest required to go and actually test the functionality of these features. The best part about this repo is that it's set up with a dev container. So you can try this out on your own simply by running this dev container in GitHub Codespaces. If you go to this repository, which I'll have a link in the description, and go and click on Open in GitHub Codespaces, it's going to create your Kubernetes cluster with kind, deploy Argo CD, and deploy an app of apps that deploys the rest of the applications that test out this new functionality. So you can test this out all on your own without having to spin up your own environment. You can test it directly in GitHub Codespaces. So starting off with the addition of the templatePatch field on ApplicationSets. So with this new feature, you can define templates without being limited to string-only fields. This gives you more granular control over your configurations. For example, you can toggle fields under the source to generate applications from different repositories, such as Helm charts from Bitnami and customized packages from private repos. One of the most common use cases for this feature is toggling auto sync on and off using values from the ApplicationSet generators. This is a very common practice with end users are testing changes against a specific environment and they don't want the changes to be erased if there is a commit in Git. Other examples might include using Helm and Kustomize in the same application set, and you want to include fields specific to those sources. So you want to use source.helm.values files and Kustomize.components on different applications generated by the same application set. Also, having conditional ignore differences when using an application set. So for example, if you're deploying cluster services like Kyverno and Crossplane, but only the application running Crossplane needs to ignore certain fields. So in this example I'm going to be going through today, each element in the list generator will specify the environment name, whether or not to enable autosync, and whether or not to enable pruning of resources when using autosync. We're going to deploy the dev, stage, and prod environments using this application set. And so this list generator is going to work in tandem with the new templatePatch field. So each item from the generator specifies autosync, and if it specifies that, the templatePatch is going to add in the automated sync policy to the application spec. And if prune is also enabled, it's going to include that in the automated sync policy configuration. So if we jump over to Argo CD here, we can see that my application set has indeed deployed the 3 guestbook applications, one for each environment. So dev is going to have autosync and pruning enabled. Staging is going to have autosync enabled, but pruning false. And prod, we're not going to autosync, which means we're also not going to prune resources. And if we look at staging, we can see that autosync is enabled, but pruning of resources is not. And we can see that the prod application hasn't synced at all because we haven't enabled autosync. This feature is really powerful for adding another dynamic element to your application generation, meaning that you can really play with when certain fields are going to be enabled. When application sets were first introduced into Argo CD, one of my hesitations was the variation of fields required in all of the applications that I was managing. I could use a Git generator to pick up all of the folders that I already had in Git that defined the delineation between different applications, but I couldn't get it so that certain applications had different fields compared to the default that I want for all of my, say, cluster services applications. This template patch functionality adds a whole other element of dynamic templating when generating applications. Another great example is the ability to specify a list in the values from an element from a generator and then use that in the template. So normally you're limited to string only fields like the cluster name. That's just a string. But the values files here is a list of other strings. So with the default template field, you're not able to simply list the values file field to populate the values files for the source. But now with the addition of the template patch, you can use a range to iterate over that list of values files and add it to the source.helm values files field. Now, it's important to note that when writing a template patch, you are crafting a patch. So if the patch includes an empty spec, it will effectively clear out the existing fields. So for an example of this behavior, say you have the template patch like this, where spec is outside of the conditional statement. For the prod environment, which is not going to enable autosync, this field is not going to get included, and all that's left in the template patch is just spec : an empty spec. The result is that you're going to end up with essentially an empty spec for the generated application because the template patch is wiping out the existing fields. The project field only still gets templated out because of a security feature, but the destination and source are empty or missing. So the solution to this is to ensure that when you have conditionals, you don't have a situation where you end up with an empty spec. So for the issue that I ran into, the solution was to put the conditional to include the empty spec field, which meant that when autosync is not enabled, the template patch was empty and didn't wipe out the rest of the existing fields. The next feature I want to cover is ServerSideDiff. So Argo CD's main diff strategy uses a three-way comparison between the live, desired, and last applied configuration states. However, with the introduction of server-side apply, SSA, a new sync option in version 2.5, the project implemented a new diff logic based on the Kubernetes library called structured merge diff. Since then, they've learned from the community about the various limitations with this approach. To address the issues, they're introducing a new diff option that performs a server-side apply in dry run mode to determine the predicted live state. By comparing the server-side apply response with the live state, it'll give Argo CD a more accurate and efficient assessment of syncing resources. So this server-side diff will also address the limitation where admission controllers with mutating webhooks are only executed in the cluster, which leads to a diff between the desired state before the mutation and the live state after the mutation. So as an example of this, I've got Kyverno installed into my Kubernetes cluster with this mutating cluster policy, which for any deployment in the server-side diff namespace that includes images with the latest tag, it's going to mutate those deployments to use the image pull policy always, meaning that every time the container is deployed, it'll make sure to try to pull the image with the latest tag. The problem is that if I define a deployment in Git with the image pull policy not set to always, so if I look at my desired state here, in Git, I've set my image pull policy to if not present. I'm not aware that it's best practice to use always when using the latest tag. And that's why the cluster administrators have this mutate policy that will resolve that for me automatically, and it's not a concern to me as an end user. The problem is that this introduces a persistent diff to Argo CD. because when it's not using server-side apply and dry run when doing the diffing, the live state is always going to be different from the desired state because I've got this cluster policy mutating the resource as it's deployed to the cluster. So you'll see here, I've got this application with autosync enabled, and you'll see that it's syncing every few seconds because it's trying to reconcile that difference created by the mutating admission webhook. The solution to this is to add an annotation to your Argo CD application, which adds two compare options. The first is it sets ServerSideDiff to true, so it's going to use a server-side apply and dry run to diff the difference between the desired and live state, and to enable the inclusion of mutating webhooks in that ServerSideDiff run, which isn't enabled by default, so it's important when you're using something like Kyverno to include that annotation. So I've updated my Argo CD application to use that annotation, and you'll see that the diff has gone away. If I look at the deployment, there's no diff between the live and desired state now because it's including that mutating webhook when determining the difference between those states. The application is now taking into account the result of that Kyverno mutating webhook. There's also another interesting problem that ServerSideDiff solves, which is this challenge with outdated managed fields on a resource. So if you take something like an ingress resource that has an outdated API version in the managed fields, say for example, I've got networking v1 beta 1, but if you compare that to the resource that is being applied to the cluster, which is now an updated networking v1 without the beta version, you'll see that the API version is different, which results in an error calculating the diff because it's attempting to convert the newer API version to the old API version, which is an unknown conversion. This problem is addressed with ServerSideDiff because it's now using the Kube API server instead of the client side to determine any potential diff. In 2.10, there's now support for Kustomize Components directly in the application manifest. So for context, Kustomize Components encapsulate both resources and patches together. They essentially provide a powerful way to modularize and reuse configuration in Kubernetes applications. The example I'm going to show here is loosely based on the components example from the Kustomize project. I have a base which deploys a deployment and a config map using the config map generator. And I also have this component folder which has a patch for the deployment and an additional config map. So normally I would have to go and include the components in the customization.yaml file that the Argo CD application is sourcing. But now with the addition of this feature in Argo CD 2.10, you can specify directly in the application manifest which components you want to include with that customization. Now on the surface, this is essentially a one-to-one feature-wise. You could either specify it in the customization.yaml or you could specify it in the application manifest. The true value of this functionality is that when you have an application set, you can dynamically specify which customized components you want to include based on the elements produced by the generator. So for example, if I have a database component that I only want to include on applications that have the database label, I can use the result from the application set in the template for the application to specify to include that component based on that condition. This pairs really well with the templatePatch functionality in that you can now do logic on the template for the application to say only in these conditions do I want to include this customized component. The next feature I want to talk about is the addition of the PostDelete hook, which is used to clean up resources after an application has been deleted. So consider the scenario where you use a pre-sync hook to create any resources that your application might rely on that maybe is outside of the Kubernetes cluster, you're interacting with the API for another service. But when you go to delete the application, you need to then clean up those resources that you created with that post-sync job. Now you can use a post-delete job to go and clean up those resources for you after all of the resources in the application have been deleted. So for an example here, I'm going to go ahead and delete this application. So if I use a foreground delete here, you'll see all of the resources get deleted. Then it spins up the post-delete hook job. Once that's successful, the application is fully deleted and removed. This next feature is a really interesting case of the type of challenges that you can face when operating Argo CD at scale. So the original issue here is that whenever the timeout.reconciliation value, which by default is 3 minutes, is hit, the controller triggers a refresh of all of the applications to the repo server. So it's essentially telling it it's time to check again to see if there were any changes to these applications in their source, in their desired state. The problem comes when you have a high number of applications. This creates spikes, CPU spikes on the controller, and especially on the repo server when monorepos are in use for multiple applications. So you've got one repository that a number of applications are referencing, and they all get triggered at the same time to refresh, which means the repo server is doing all of this work at once. Now, each refresh will evaluate the app, and if apps are configured with the revision head, i.e. the tip of the main branch, and a new commit is present on that repo, the repo server has to regenerate the manifest for all of those applications, which is the most expensive operation that it can do. Running Helm and running Kustomize requires a lot of compute. So in the case of this user, it triggers Helm templates on the repo server, and then it's flooded with requests. So their proposal was to implement a jitter to the reconciliation. So how the jitter works is that it's added to the sync timeout, and it'll spread out the refreshes, giving the repo server time to catch up, to process the requests over a longer period of time instead of coming in as one spike of requests. So the jitter becomes the maximum duration that can be added to the sync timeout. So for example, if the default sync timeout is 3 minutes and you've got a jitter of 1 minute, then the actual timeout will be between 3 and 4 minutes. And this is configured via the Argo CD reconciliation jitter environment variable, and is also available as an attribute of the Argo CD config map. So in the case of this user who tried out the jitter implementation on version 2.10, they said that the results were incredible, that they no longer face any delay at all in the Argo CD UI, and when they delete a pod, the new pod appears instantly. And in this case, they have 2.7 thousand applications, which many monorepos being in use, so multiple applications that are all sourcing the same repository, which means when there's a new commit, they all end up regenerating the manifests. So as you can see, this feature has a huge impact on the performance with just the simple implementation of spreading out the load over a broader period of time, which saves both on the resources for the repo server, because you no longer have to handle really large spikes. You can spread that over less resources over more time. And it improves the user experience where the UI is now more performant because there isn't this huge delay caused by the repo server. The next feature is the addition of self-serviced notification configurations for Argo CD applications that run in namespaces other than where Argo CD is running. So the idea here is that you can run applications in any namespace if you configure Argo CD to support this mode. And what this promotes is it allows developers to manage their application manifest in their own namespaces without having to have access to the Argo CD system. What this feature added in 2.10 does is it allows them, the developers managing their own applications in their own namespaces, to also manage the notifications configuration alongside those applications in their namespaces. So to enable this functionality, you have to pass to the notifications controller the application namespaces flag and enable self-service notifications. You can conveniently pass this to the notifications controller using the Argo CD CMD params config map, using the application.namespaces, and the notification controller.selfservice.enable flag. And so what this allows the developers to do is they can then configure the Argo CD notifications config map in the same namespace as their applications, the actual application manifests that they're not managing, not just the destination of those applications that they're managing. And they can also include the secret for that notification service. So this is really convenient if your developer team is managing their own notification service. So say they've got their own PagerDuty account and they're the ones that have access to the credentials to integrate that with Argo CD notifications. They can now self-manage the secret that authenticates the notifications controller to that service that they want to send notifications to. And then because they're managing those application manifests themselves in their own namespace, they can also go ahead and do the last configuration, which is the notification annotation on the application to say that they want to receive these notifications to that service that they configured themselves. The last feature that I want to cover here is the addition of status panel extensions. So when we're in Argo CD, the status panel refers to this section here that includes the app health, the sync status, and the last sync's result. But you notice that there's some blank space over here that could be used to provide useful information about the application. Well, with the addition of this new feature, you can provide custom extensions that will populate information in that status panel. So the example given in the pull request that introduced this feature is a new status section for progressive syncs on applications. So basically saying the status of that progressive sync for the application that's using it. And so this is taking advantage of their open source extension for progressive syncs. So essentially, this new status extension can provide better feedback to developers who are using applications that are a part of the progressive sync of an application set. The installation of the extension is fairly easy. The Argo project provides an image for installing extensions, and then you provide that as an init container on the Argo CD server deployment. But by providing it an environment variable with the URL, the checksum for that URL, and the volume mount, it'll make the extension available in the Argo CD UI so that you can now see the status of your progressive sync. I'll include a link to my GitHub repository with all of the example configurations in the description down below. Thank you for watching this video on what's new in Argo CD 2.10. If you're interested in more Argo project related content, check out the Acuity YouTube channel. You can find me on LinkedIn or the CNCF Slack channels, which I'll leave links to both of those in the description down below. If you'd like to get started with Argo CD without any concern for the underlying infrastructure using an innovative agent-based approach, check out the Acuity platform and the Getting Started guide that I'll include in the description.